Alright, Algebra 1. Moving on with inequalities here. We're in 3.6 now. Compound inequalities. Our essential question is, how do you solve and graph inequalities containing the word and or the word or? Okay. Basically, what we're looking at here is two inequalities put together. What is a compound inequality? It consists of two distinct inequalities joined by the word and or the word or. Okay. Each of these has their own little thing here, but we're basically solving them the same way, graphing them the same way. Okay, we just got to understand when we look at it that it's two inequalities in one. Okay, for example, write the inequality for all real numbers that are greater than -2 and less than 6. Okay, we want those numbers that are greater than -2, x is greater than -2, we're eating up the x, but yet that x, that real number, that's less than 6. And graphically, you'd have the circle at -2 because there's no equal, and you'd shade to the right because x is greater. And here you'd have the circle on 6 and x is shaded to the left because x is less than. So we're looking for the real numbers between -2 and 6. That's an and problem. Okay, any number in there would solve this one and that one. Okay, so it's one or the other. So how does that look in a problem? Let's take a look here. Solve for m. -3 is less than or equal to m plus 4 minus 1. What this really is this inequality, m minus 4 less than -1, and it's -3 is less than or equal to m minus 4. Okay? We just write them together in a compound form. And you can do it this way with an and. So how do you solve it? You solve it just like we've been doing. Add the 4, only now add it to both sides. Okay? Cancels here. We get 1 less than or equal to m less than 3. Okay? You would solve it just like we've been solving. If there was a 2m right there, then we would divide everything through by 2. Okay? You just solve it like we always have been. Just do the same to both sides as well as in the middle. And then graphically, you could take this so 1, 2, 3, we have a dot at 1, and m is greater, so we're going to go to the right. M is less than 3, so we'd have a circle here. So it's everything between 1 and 3. Okay, notice it's in between it. It's intersecting there. They intersect as you go across. Okay, and that happens almost all the time with a compound inequality that's an and. So, very similar to what we've been doing. What about the ors? How about an or inequality? Okay, writing an inequality for all real numbers, and that double bar r, that's a shorthand way for writing real numbers. All real numbers that are less than 0 or greater than or equal to 5. Think about that. You're less than 0, but you're also could be greater than or equal to 5. There's no intersection there. And you'll notice by the graphs, you kind of get that longhorn effect. Okay, there's no intersection most of the time. Usually with an or, the inequalities do not intersect. Okay, most of the time. Nothing's perfect, but most of the time that's what you're going to see. Okay, and that's what separates the and the or problems. So let's take a look at how you'd solve that. That should look real familiar to you. That's just solving the two inequalities just the way they are. We don't combine them like the and problems. Okay, it's usually either you're going to find a t that solves this problem or a number for t that solves this problem. Okay, you're usually not going to find one with an or that solves both of them. Solve it like we've been. Get rid of addition and subtraction first by doing the opposite operation. So subtract the 2 from both sides. Bring down your 3t, divide out the 3 because that's multiplication, so you divide to undo that. Do not flip your inequality because you divided by a positive. So t is less than -3. Circle, going to the left, less than. Over here, subtract the 5 from both sides. Now we divide by the -4 to undo the multiplication there. And because that's a negative we divided by, I flip my inequality symbol. T greater than 1, put the circle on 1 and going to the right. Okay? All this should look very familiar to you because this is what we've been doing this chapter. The technique is very much the same. You just got to kind of understand what you're looking at. Okay, if it's an and, we should get an intersection on the graph. It looks like you get the two inequalities in the same problem. Okay, so if you're going to add or subtract first, do it from both ends as well as the middle. And then get rid of any multiplication and division the same way. Divide or multiply on both sides. And then in the middle, if it's a negative you're multiplying or dividing by, flip both inequalities. Okay, here you're just getting two separate problems. Just solve them each individually, just like we've been doing. And you should notice that most of the time the graph does that. Okay, they go opposite each other. Okay, so when you get into class, we'll look at problems here, and then we'll look at some application of it. Again, we'll just keep on working this stuff. We need to get better at solving equations, whether it's just straight linear equations or inequalities. We need to get better at this. We've spent quite a bit of time on it, so hopefully I can see that most of you are starting to get it. Some of you it's pretty easy for you. Others are coming along. Just keep working at it, okay? And that's how you get better. All right, we'll see you in class tomorrow. Have a good one. Bye.